Hello. Good evening, everyone. Thank you for joining us for this discussion on MaaS, Mathematics, Science, and Engineering.
Ma'am, we cannot hear you anymore. We heard good evening, everyone, and then I think you got muted.
This time, we are working with smart cities and mobility. The title proposes a groundbreaking urban transportation framework achieved by deeply integrating the Internet of Vehicles, IoV, and Mobility as a Service, MaaS. IoV provides the essential technology layer connecting cars, infrastructure, and the cloud to generate real time, high quality data on traffic flow, congestion, and vehicle status. The true value lies in feeding this dynamic data into the user facing MaaS platform. MaaS combines all transit options, buses, ride shares, bikes into a single app, and when powered by IoV, it can intelligently optimize multimodal routes with speed and energy efficiency, process integrated payments, and enable predictive transit decisions. Now, let us give a moment to discuss about HITAM and the ATAL program. Let me introduce you to this. HITAM is a top ranking autonomous engineering college with 25 years of exemplary legacy. It stands out with its unique doing engineering methodology by offering engineering education that enables students to become hands on engineers. HITAM implements the best practices developed in collaboration with world class partner institutions to create unique learning experiences for students. With initiatives like project based learning, PBL, and experiential platform to learn and for outreach in real time engineering, such as Explore, students at HITAM can reach beyond the classroom. The computer science and engineering department is witnessing a period of exciting growth and opportunity propelled by the growth of technology and its recognition through excellence with the mission to create learning environments to transform the students with strong fundamentals in computer science, analytical programming, and problem solving skills. This faculty development program is designed to empower educators and researchers with the knowledge and tools to engage the emerging uh, sub smart urban mobility solutions. The focus is on the convergence of Internet of Vehicles and mobility as a service to build sustainable, connected, and user centric transportation systems for the cities of the future. Now, let us hear from someone that I have personally been inspired by a lot. I am speaking about Dr. Soham Sohoni, the director at HITAM. Dr. Soham Sohoni, as the director of Hyderabad Institute of Technology and Management, has spent over 26 years in the United States, primarily in academia. His research is in computer engineering and engineering education. He is interested in adoption and translation of effective teaching techniques and has established a vision for networks of discipline based education. Ambassadors facilitate the adoption and evaluation of effective pedagogical studies. A computer architecture visualization platform that he and his students designed has been used by thousands of students at three universities in the US. He has published over 40 peer reviewed papers in the top journals and conferences in both his research areas. He has received a Best Paper Award for his work in computer engineering from the IETE Technical Review Journal and three Best Paper Awards for his work in engineering education from the American Society for Engineering Education. He is popular and well respected as an instructor and has received many training awards, including Regents Distinguished Teaching Award in 2010 at the Oklahoma State University. Dr. Sohoni is a member of ACM, Association of Computing Machinery, and ASEE, American Society for Engineering Education, and a senior member at IEEE, Institute of Electrical and Electronics Engineers. He has reviewed for various journals and conferences and served as a session chair at a number of conferences. He is a member of the board of the Indo-Universal Collaboration for Engineering Education (IUCEE) and the Journal of Engineering Education Transformations. He also serves as a program evaluator for the Accreditation Board for Engineering and Technology. Now, I would like to hand over the stage to Dr. Soham Sohoni to address the gathering. Over to you, sir.
Yes, thank you so much for that introduction. I'm very grateful to have the opportunity to launch this FDP. I thank Dr. T. Satish, our Associate Dean in Computer Science and Engineering, for giving me this chance to launch this FDP. And it sounds like a very exciting topic, something that I wasn't all that familiar with. In fact, when the invitation came through, I asked, what does IoV stand for? And what does MaaS stand for? Because these are, uh, I think, cutting edge terms that we should all be familiar with. And so I'm very appreciative of whoever put together this FDP and the effort that has gone into creating this knowledge for all of us to learn from. And in particular, I also want to thank everybody for making the commitment to be part of this FDP, because we have a long work day, and at the end of that work day from 6 to 8 p.m., you're now committing to learn some more, to spend some more time in making in improving yourself by participating in this FDP. So I appreciate the commitment that you have shown. And I hope that you get the most out of this. And obviously, the best way to get the most out of anything is to put in the right amount of effort yourself, because that's how the more you put in, the more you get out of something. So I don't want to keep this very long. In fact, my goal was to keep my speech shorter than my introduction, which I think I have been able to accomplish. So please go ahead, enjoy yourselves, and I hope you learn something valuable through this experience. Thank you.
Thank you so much, sir. Next up, I would like to introduce, just a minute. Next up, I would like to introduce Dr. S. Arvind, who is the principal at HITM and a professor and our esteemed principal. Do we have sir in the meeting? All right. So next up, I would like to go and introduce our next speaker, Dr. T. Satish Kumar, who is the Associate Dean of Computer Science and Engineering. He has 25 plus years of experience in academia, industry, and government funded projects with expertise in life skills and soft skills training, problem based learning, and curriculum development. He has a proven track record in training and placement, administration, and ERP implementation for the education sector. He has an extensive experience in e learning and skill development programs. He has published 20 plus Scopus or WOS indexed papers, 3 patents, and a book. He has a strong background in emerging technologies, system design, and quality assurance. He is adept at strategic planning, team leadership, and stakeholder management. Now, I would like to hand over the stage to Dr. T. Satish Kumar.
Ah, Good evening and a warm welcome to all the esteemed resource persons, faculty members, researchers, and participants joining us from across and beyond the country. We are incredibly launching the privilege to inaugurate the 6 days online faculty development program on the topic that is not just relevant but critical for our future. A smart and sustainable transportation framework, integrating of IoV, we call it as Internet of Vehicles and Mobility as a Service for our future urban mobility. This FDP is proudly sponsored by AICT, Atal Academy, an initiative we are deeply grateful for us to enable us to bring together such brilliant minds to design and discuss the future of urban transportation. The way we move within our cities, it's a pivotal gesture. With a rapid urbanization, growing environment concern, and incredible technology advancement, the concept of IoV and MaaS are no longer just a futuristic idea. They are the essential building blocks for creating the smooth, efficient, and sustainable cities for tomorrow. Our aim over the next 6 days is to delve deep into the integration. We will explore how connecting vehicles, infrastructure, and user can create a seamless data-driven ecosystems. And however, service-based mobility models can redefine our daily life. To guide us through the complex and fascinating journey, we have assembled a truly exceptional panel of members for us for the FDPs. Day one, I think so, Dr. Raman sir from CBIT Hyderabad will ground us the foundational principles for this 6 days of FTP program. This FTP has meticulously organized by Computer Science and Engineering Department, the team of HITO. We encourage all of you to actively participate, ask questions, engage in the discussions. This is your opportunity to learn from the best, network with peers, and contribute to shaping the future of urban mobility. Once again, a heartfelt welcome to you all. Let's make next 6 days an insightful experience. Thank you. And without any further delay, let us begin this existing intellectual journey. Thanks you one and all.
Thank you so much, sir, for those insightful words. Now, I would uh, like to mention that we will be beginning at 6:30 sharp with our first speaker. And until then, I request everybody to kindly wait. Thank you.
Hello, everybody. Now, let us dive into the first session, Introduction to Smart Urban Mobility Concepts and Challenges, which will be taken over by Mr. Somashekar Gupta. Mr. Somashekar Gupta is a distinguished global product manager recognized for delivering innovative and high impact products across the domains of IoT, cloud computing, SaaS based applications, hardware, and firmware. With a core focus on blending company vision with market reality, Dr. Gupta excels at transforming complex technological ideas into clear, sustainable business strategies that drive measurable growth. His expertise spans the entire product lifestyle, from product portfolio management and global market evaluation to meticulous roadmap development and flawless international product launches. Dr. Gupta is highly skilled in designing and delivering connected systems that prioritize enhanced user experiences, scalable business opportunities, particularly in the realm of IoT and cloud solutions. His approach is defined by a customer centric, forward thinking mindset aimed at maximizing ROI and promoting competitive differentiation. I would now like to hand over the stage to our first speaker, Mr. Somashekar Gupta. Over to you, sir.
Can you hear me well?
Yes, sir.
Yes, ma'am. Thank you. Thanks. Okay. Can I share the screen myself?
Yes, you can say.
Yeah. Okay. Okay. You should see the content coming up. Okay. Is it okay now? Can you see the full screen in the content?
Yes.
Okay. Thank you. Thank you very much. Thank you, ma'am. Okay. So the today's topic is about. I am just trying to figure out how to minimize things. Give me a minute. Yes. Okay. Now you should see everything fine. Okay. Thank you. Okay, so today's topic is a more complex topic, I would say, and which is still needs a lot of developments, a lot of evolution is still required. But the selection of this topic, I'm not sure who has done it, but this is very, very much important topic in today's revolutionary technical developments, and this is a very unmatured topic still, and this required to have all our lifestyles improved in a better way for next generations, and this is needed to be not only from a technical developments point of view. This also needs to go to governments, also needs to go to every technological company who are working and developing the smart infrastructure uh, to have the better future, right? So I won't be able to give you more research specific information on this, but I will give you more of what is the complexity, and what are the challenges, and what how governments, how we can influence as a front facing to a technology companies. And as you are mostly into faculty and faculty and giving guidance to next generations, giving guidance to future generations of engineers, how we all together contribute to the society uh, in this smart urban mobility, right? So that much I can give you. So because I wanted to set expectations right, so that this is just a basic and fundamentals where we can put them right, so that we can prepare a better future for all ourselves. Okay. So ma'am, remind me in between if I am deviating, or if you see any questions in the chat. Also, maybe we can take it up in between. It's better to take up questions whenever there is a question raised by any faculty members in the chat. So feel free to add any question, ask any question during the presentation. I will be able to come back and give more clarity what I mean and what I wanted to share with you all today. Yeah, keeping that in mind, so thank you for the faculty members of Hitam who chosen me to talk about this wonderful topic. I like this topic, and I am working on some of these aspects today. You can see wherever there is a street light in this picture, I am part of development and looking at the street light. Raghu sir, can you see the cursor as well, which I am moving?
Yes, yes, it is
The
visible.
pointer also? Okay, good.
Yes, yes.
Thank you. Thank you. So, and I myself, I am focused into street lights. Also, right now we are building solar street lights also into connected world, where it can influence the public, also highways and roads infrastructure, which could give us more um, sustainability, right? So you can see many aspects in this picture. So it is about livability, living experience. It's about experience where we live in the cities, experience where we live in villages, experience where we have more of EV related aspects are going on, and then more of infrastructure related. So the study says today, I think by 2030, around 40% of people will be moving from urban areas to the more of city infrastructure and city culture, right? So yeah, I remember my olden days when we were living in the village in India, southern part of India. So we had at least every um, morning buses used to come, and then evening buses used to come. Now all of them are moved to, buses are gone, moved to a small vehicles like autos or things like that. And where the buses are running and autos are giving more pollution, right? So a bus gives less pollution, also more people to take, but auto gives more pollution, less people to take. So that is where the urban mobility sustainability is taking away because of our fast cultural life, and we want everything to be faster, everything to be completed in a quick time. So but we should not forget about sustainability when we are growing in the technical world. Okay, so the sustainability and smart urban mobility starts with the technology, data, how we use technology, how we use data, along with the innovation approach to more efficiently and safely. So that's what I mean. The sustainable urban mobility definition could be, right? So the goal of our today's session, as I said, also for the future generations, right? We will try to address what are the sustainable urban mobility problems we have, how we can reduce, look at some kind of traffic congestions, what we see in every day in the cities, how we can minimize those, and then transportation equality, also how to bring in these things into smart city framework so that it is all inbuilt into um, the infrastructure of a future generation future. Yeah, so that will improve the quality of life, right? So that's where we go and then look for a better quality of life. And also we see a trend now, moving out from cities to again back into urban living and rural living. That is also happening nowadays. I hear many of my friends who are elders, who are brothers, who were moved out from cities in 1980s 1990s. They wanted to go back and then live village life and rural life again. So that is also happening as a trend now, because they don't wanted to live in the polluted fast moving world, and they want to go back and then live in the peaceful world. That's also happening at one end, but at the same time non compromising the technology and non-compromising whatever is happening, right? So uh, this is all related to the mobility. Okay, urban mobility is including not only talking about transportation, also including the transportation into the more of living life within the cities. So the act of moving somewhere to somewhere is called urban mobility. What is the significance to the study of urban mobility, right? So what significance it is? It is a social living, improving the social living, understanding and improving the mobility of social living with a better quality of life. And second is in the mobility cultures, we lead livability and then city world. We see every day, day in, day out, the living style in the cities is becoming poor because the infrastructure of the cities are not able to expand to the people intake into the cities. So the urban mobility schemes, whatever was coming from the governments, whatever is taken out by the big players of municipality developments, also also the real estate is not able to carry out because their vision is becoming only 2 to 3 years, not 30 to 50 years of vision. So I see some of the very big examples here. I remember going to China in 2000, 2005 time frame. There in 2005, we are talking 20 years ago, right? So there I see the development is huge when it comes to airports, when it comes to living standards, when it comes to the road infrastructure. So they have chosen to make infrastructure 50 years, 100 years ahead. But today we are still doing very, very slow development in this because of whatever reasons, right? It's not pointing somebody, but those are the reasons. So I am going to give my thoughts about what could change our mindset so that it will be helpful for the future generations to come, right? So mobility plays a major role and which needs to be within the economical conditions of living standards what we have today. It could also lead to reduced costs. It will be more efficient ways to manage urban environment, also those to be more sustainable. We will also see some examples today, some of the cities examples where they took these very strong initiatives before they see this could happen. That's the reason the cities were very, very successful, and those are tier 1, tier 2 cities which are very nice in urban mobility with sustainable growth. So in the sustainable mobility, we recognize three aspects. Sustainable mobility as a system, we see here there are bicycles who could use bicycle to commute to a place to another place, who could use metros, trains, transportation to commute one place to another place, and then bus, and then private cars and other things. So these are the 3 or 4 different aspects which needs to be seamlessly integrated by one and the other so that the sustainable ecosystem is built within the cities, and which will help to be more safer in the city, also not compromising on longer time to work. Also it is supporting each other in the economical conditions. So for example, I would say I live in a city very close to Cambridge in the United Kingdom. I like this Cambridge infrastructure. Why I like it is they have different, all in the whole overall city, maybe 3 4 miles away, 4 miles away from the city, they have a parking lots where it's a public parking, it's a free parking space. From there they put an electric bus to the city. So if I go with my car into the city, I have to pay more parking charges, one, and I need to pay the congestion charges into the city because I am driving with my car, which is having more pollution, and which is, if I want to go and then come back, it is not viable, and it is actually spend rather than I go to this parking. It's called park and ride. I go to this parking space and I park my car there. It is free of cost. I take a public bus, so which is very convenient into the city. which will take only 10 minutes to 15 minutes maximum. And then I reach wherever I want to go. I work, I come back, return on the same bus, and take my car, come home. So, which will allow us to take less time, less hazard. I don't need to look for different parking places, and I don't need to do anything. Also, there are some facilities provided near to the train stations where I can do bicycle to the train station. I go on my bicycle, I park bicycle there, I keep it, go in the train, and then come back, take my bicycle, come home. So these are efficient, more affordable ways where the public infrastructure can become more sustainable, also more mobility constraint, which will be helping commuters at the same time society. So, and then that's one of the example, right? So that will enhances our human experience. It is cost effective, also it is efficient way of doing it. And if if we wanted to do that, it is a social environment taken care, also efficiency taken care, and it is less resources are used there, and it is more energy constraints. So these are the special benefits where we can do if we have the sustainable infrastructure in place. So, and um, basic characteristics for making this sustainable mobility and urban mobility, right? So another aspects are like innovation can be included. Another thing is the clean transport modes. So it is influencing social physical systems. Also transportation should have land usage, also transportation usage and environmental usage is more safer, so that we are not disturbing anything in the environment. It is also gives a very social effect, and there are many other aspects can be taken care. um, so it needs to be developed more it needs more adequate management, also special governance is required. These are the couple of basic characteristics which needs to be taken care while keeping the sustainability mobility moving forward. So this I could find in this how we can make this one more efficient in not compromising the environment, economical, also social. So these are a couple of sustainable mobility goals, I would think. So I try to plot like, okay, so there are economics. One is cost management, economical conditions. Another thing is environment, and then social effects. So on the social effects, more is affordability. Am I affordable to the sustainable mobility or not? If I'm using transportation, or if I'm doing human safety, health measures, accessibility and equality. At the same time, environment. Are we consuming more environmental resources to move the mobility? Are we protecting environment to move our mobility? Are we looking at all our integrated systems to be used when we are doing this sustainable mobility, right? So, and another aspect is economics. Operational efficiency is also another very big aspect when we are looking at economical sustainable growth. So do we have any questions or anything on the previous slides? Okay, so I move on. Um, okay, so we will move on to sustainable principles. Okay, I was reading about what are the goals or principles which we need to look at uh, when we are doing sustainable mobility growth in the urban living. So I could come across couple of principles. Those are very helpful to do planning also for transportation related aspects. So the transportation of we need integrated transportation and also land use planning. So the transportation also land use should be utilized in a combination use. So the then the planning of urban environment will be very nice to grow the sustainability and protecting environment. So all sustainability will start with protecting environment. That's the first thing. You say it could be go green, it could be less power consumption, it could be renewable energy, using green energy, using ecological energy sources. So um, alternative vehicle managements. So all of these together comes under looking at environmental protection. Efficiency is also improves when we have better environment protection there. It could be usage of natural gases, it could be usage of less air pollutants. All of these contributes to the overall sustainable environment. So social objectives again, right? So when we are growing into this sustainable mobility, are we disturbing any social objectives? Livability, also social ecosystem, urban social living. So that's the reason the more of cultural differences are going to come if we have any disturbances with the social living. So this overall improves the economical development at the same time, right? So when we have this infrastructure is building up, the infrastructure building up, definitely there is an infrastructure up. That up will give the economical growth to the whole world. At the same time, this economical growth will give opportunities, will open up more new opportunities, and also utilizes the existing resources what we have um, in the in the different types of modes. So there are different strategic approaches. Those strategic approaches also will indicate the straight framework which will improve the community goals. It will improve the mobility systems. Also, it will improve the economical uh, conditions of each individual with the social living. So here the transportation also has different types of modes. So what is different types of modes so that it is more sustainable transport, right? Okay. So this is kind of a food pyramid, right? Okay. So where if we are using more cars, private cars, we are burning more money. Also, the less people are moving from one place to another place, which is less sustainable. Second aspect is like, okay, so you have a shared mobility, shared usage, where the shared usage is going to be shared between many people, which will improve little bit more sustainable. If it is public transport, which is better when we are looking at during these, so more electric vehicles could be, more EV vehicles could come into the sustainable mobility, sustainable moving, more of sharing, more of carpooling, more of vehicle pooling, whatever, right? So those are, and then the better way of doing it is cycling, but with the cycling we can't go far. And so our living also needs to make change. So we will look at some infrastructural differences, with some kind of grid mechanisms where we can solve these problems in a better way, so that it is more sustainable in the transportation world. Also, the walking is better, which is anyway no consumption of anything, and which is more sustainable, right? And then, so these are different types of modes. Again, it's strategic transportation, which will be giving us transportation demand management. So the demand of vehicles, demand of incoming, is depending on the people coming into the cities, right? So that's where the congestion will be reduced, which will improve the future of city, and then also the more less pollutants could come into the cities. So efficient way of transportation, with more supply friendly, and identifying different strategics, multimodal capacity of current infrastructure. So this is one of the aspect which I would say is well defined in developed cities, you can see like Paris, one of the example I could say. Also, London infrastructure is also another example, which is using this transportation with very efficiently. Like, okay, so if someone wants to go to his work location from his home, so most of the times they have metro, but to reach to the metro is not easy because they needs to take again a bus or something, right? So rather they can take their own bicycle or EV scooter, and the EV scooter they can take, and then that can carried within the metro, um, and also in the public transportation. Then once they got down, they can use their EV scooter to go to their work location, where the EV charging facilities are provided in the office space, and they can get it charged and come back home in the same way. But I see this is moving forward will become very big, and which will also enable non you we do not need to use more vehicles here, but this really needs infrastructure development to be there, because the safety concerns could come if you are driving on the same car path or bus path. We will also see some models where the smart mobility could improve better with the future generation, so that the infrastructure is there to use these kind of innovative methods. So to make these ones, the strategic priorities, development priorities, the management priorities needs to start from infrastructure development. These infrastructure developments needs to be starting with the exploration, and then making those decisions at the right time, so that the installations could happen, and those move to implementation, and then the availability of development. Also, this needs cost, right? So it's nothing comes for free, so which will also improve. Lot of financial guidance is required to the governments, also to the management, financial institutions, to start funding and start looking at the gaps in the overall infrastructure. Also, it improves the overall living standards. So once we have done these improvements are happened, and cost we spent, but what is the return on investment, right? So whether those investments are happened on a right way, or return on investment is properly monitored or not. There should be definitely a framework which could improve overall. To If there is no framework, it is all done and then dusted, it is not going to be giving any indication factors that the improvement has been happened. And there are key identifications, key performance indications. For example, we have done this investment, and this investment is running with so xy, and then this is the less. Recently I remember reading about some article about Hyderabad metro investment versus return on investment for last 2 years, which is going very very low indicator. So maybe there are some kind of indications, because wrong predictions also could happen because of the because of whatever reasons. So maybe the planning is wrong, it took more over planning, it took more infrastructure development. Also the delays in constructions could be one of the aspect. And these performance indications definitely needed to be there and planned before started implementing any sustainable infrastructure developments for the future. Mm. So another thing is, it should have a public engagement. If there is no public engagement on these kind of infrastructure developments, which will not be helping anyone, it is not also helping any citizens who are living in the society, right? So that getting taking a social feedback, taking a social citizens, making them part of this infrastructure developments, sustainable growth, is going to help the cities for the future. um, okay, so there are a couple of other disciplines, right? So it is not only urban living, it is not only public mobility living. So there are urban planning is required. So you can see it on the slide, like relationship with other disciplines, what different relationships we have between mobility and also different geographical relations. So when we are doing any urban planning, transportation, environment and geographical things goes all in hand. So when when the transportation planning is happening, during the transportation planning, definitely urban planning should happen along with the environment and geographical infrastructure. Anything is not done in the right way, they have to come back and then redesign one or the other, which is not going to be sustainable. For example, we have seen many places in metropolitan cities where they have done the transportation planning has been done, there is a construction happened, maybe a bridge, or maybe a skywalker, or maybe underpass or a footpath or a subway or something has happened. Couple of years later, oh, this is no use, we are not able to do or it is not sufficient for the current needs, and then redo things redo things to match with the current needs again redo things match with the current needs again. So this is very bad way of planning, very bad way of environment. Also we are burning social life, also we are burning the environment as well. All of them are happening because of wrong planning. They do not look at different relationships, different disciplines, what disciplines has meaning with the one or the other. So another discipline, infrastructure is like, okay, so again come to the science and technology, economical science, economics, and the management, marketing. These four also comes together to manage all of them together with the urban planning and urban management. Okay, so what is sustainable urban transport modes? Different sustainable urban transport modes. So public transportation, there are roads, fixed routes, fixed infrastructure, which cannot be changed or modified easily. So this is once that is fixed, that road is fixed, and metro fixed and cannot be modified. But all the other sides where we can look at our social living, which is micro mobility or cycling or walking, active modes, motorized movements, can be can be together so that the urban mobility transportation modes are more sustainable. So main goals and general benefits for sustainable mobility. So when these developments are taking place, the benefits and challenges both goes hand in hand, right? So first is public health needs to be taken care, social and public health, human interaction and communication. So these will help to improve the human interactions with more affordable ways. It should become eco-friendly, cost-effective. It reduces the traffic congestion. It improves the environment, urban environment. Also, it improves the physical exercise. So this one I like more because if we are able to include within our daily routine with the transportation modes, which will our regular physical exercise completes within our office going and coming back, or going to work and coming back. Otherwise we have to look at different modes to go and then do this physical exercise on a separate mode. So also if it is flexible, it's more easier. And also the safety, road safety is another aspect of it. Challenges is physical challenges, weather conditional challenges, and safety challenges. Also long distance, right? So mostly in Indian cities, very far, um, one place to one place is very far. Work location will be far. Because of the work location is far, we tend to take motorbike, or we tend to take car to go to work and come back. Also we don't go in the public transport because it is not flexible to us, because the infrastructure is not ready to go in the bike, or go in the public transport. If the infrastructure is ready, we are happy to take modes and take and move on with the micro mobility, or cycling, walking, or so if it comes to public transportation is more of road and fixed routes, where how we can benefit from each other, right? So here there is no possibility of, the main challenge is there is no possibility of door to door solution with the fixed route bus or metro, right? So definitely the metro is fixed route. From that fixed station, fixed place, we have to continue, we have to take uh, take walking or cycling or motorbike to our destinations, right? So that is not flexible. It is never we be flexible. Also, is it time effective? Maybe yes, it is effective on the time because we are not getting into traffic. There is no traffic congestion. It actually reduces the traffic congestion if we are going on a metro, but bus may not be possible. But yeah, metro is more traffic effective and also social effective. Environment also is more beneficial. But these infrastructure, we will go and then look at some deeper plans, how this could improve our overall life. Yeah. Okay, so urban mobility system users. So who are all the different users who are using this mobility, right? So different people in the living uses this urban mobility. Also, you can see these are all different people who will be using different modes of transportation from one place to another place on their daily living. So could be immigrants, could be transport users, pedestrians, and micro mobility users, professional users who want to do the work, and passengers, drivers, car drivers, different people. Yeah. Okay. So there is a road hierarchy, street classification. Okay. So what are the different modes could help us into the more um, conventional, if we are implementing conventional and alternative modes between both of them, right? So fundamental components of transport and urban planning procedures. So these procedures are very important for a city infrastructure development. Also, there are basic planning tools should be in place so that they are more efficient and more mobile in the urban living. So this is one road hierarchy or street classification diagram. You can see the city from 2021, where they do not have any. It's a conventional city where they only have motorways. These black is motorways. You can say outer ring roads, outer roads, the black routes. They do not have anything else, and rest is all primary infrastructure development. But also they have metropolitan centers, different places. There are multiple metropolitan centers, but the transportation is congestion, and then this congestion is increasing the road congestion. Also, it is not environmental friendly. Alternatively, they could think of um, mixed a mixed transportation, saying there is a regional framework which is like motorways, at the same time the black routes. Also increase the metropolitan network, saying the metros, the blue ones, and also mixed priority, also make a mixed routes, also use sustainable modes, which we are talking right now, different sustainable modes. You make it road, metro, at the same time cycle paths, also walking paths, mixed networks. So then the distribution happens in the city, so that the congestion areas are less, so that the urban living is taken care with more sustainable ways. So here is another example where current model and super blocks model. So these are the different models which used in the in the urban living. So what is current situation and what is the super blocks, right? Okay, so you can see where um, where the single usage of right way of doing it, or you can say wrong way of doing it. But this is one of the cities in France, in Spain, Barcelona, which is more sustainable city. I think last 3 years or last 4 years, also they have got award of more sustainable mobility and planning cities. So what they have bring in this is there's a old style of model and then super blocks model. What has happened in this is, so here you can see the cars, metro, and then cycle paths are there. At the same time, in the super blocks, they bring in within these super blocks, there is no way no one can enter with the car in the super block model. So that means if somebody wants to use the car, they have to be outside the super block model, and inside is only cycle and then walking paths. This way, what happens is they are not allowing anyone into this super block with the more pollutants. So which means there is a recovery of air pollution happening within this super block. Also, the super block is more of trees and only cycling and walking paths. So the transportation is taken care, and this may not be very big in the super path, but at the same time, the healing of the environment, sustainable, and mobility is taken care. All three are taken care because of keeping this type of super blocks. So in these super blocks, mostly um, restaurants, play areas, coffee shops, and public living parks will be there in the super blocks. So the cities could come back building these kind of super blocks. So the healing of sustainability happens, the environment protection is taken care along with this type of implementations. So this is another city example, okay, where the city is not yet seen. We have not seen the city yet, right? So this is another example which you can look at, the future city of future capital city of Andhra Pradesh is where it is going to come with this kind of planning. So it's mostly how we defined here the current model and the super blocks. These super blocks are right now is the vision of vision from the government, where they are clearly mentioning about where there are passive zones, active zones, protected zones, and protected zones. So here the green zones, wherever the green zones are, those are passive zones. P2 are active zones. P3, which is blue color, is protected zones, and P3 protected zones. So the protected zones are more of sustainable environment, where there are no um, no vehicles will pass through these protected zones. So the vehicles will not be able to pass through these protected zones. So those zones are clearly protected and they are outside of the sustainable growth can happen with those. So there are defined clearly commercial zones, residential zones, and industrial zones. Hope hope whatever we are talking today are taken care in this map, and this is an example, perfect example of super blocks where the environment and the sustainable mobility uh, is taken care together. So along with that super blocks building blocks, right? So okay, multimodal corridors. So multimodal corridors needs to be inbuilt within the city infrastructure and um, within the streets, right? So okay, so here this is a traditional uh, route, hourly route. Okay, so you have different lanes, and those lanes are from one end to another end, which will transport people from place one to place two. At the same time, this is another way of doing it. So but there is a bus lane is dedicated for bus alone. There is a path, public path, where they have only parking lane is on the side, but sustainability is taken care. There are green place where this place is only for walking, also cycling, and trees are taken care along with the parking and other things. But This needs more space, where in the city infrastructure, this kind of space is not available today, and not looking at it. So at the same time, so you can see the people, how many people can live in these two different, can transport in these two environments. So the total capacity of this is only 12,300 people per hour. Okay, but here, because of the public transportation, the bus and tram and transportation is included in this, so we can transport or move more people, 330,000 people per hour in this infrastructure. More people can be moved, less people are moving in this infrastructure. So yeah, so this is the biggest difference today. We are still not moving into this type of mode to do multimodal transportation. Multimodal transportation helps us grow more. And here you can see, for a different mode, how many people can be transported per hour. So we can see here, sidewalks, footpaths are very low, only 9,000 people per hour. Protected bikeway could be 4,000 people per hour. And then mixed transportation, which is 2,800 per hour. And then on-street traffic lanes, which is metros or trams, things like that, which is more transportation per hour, and then go on like this. So this mode of multimodal corridor is the future. Also includes our environment friendly and then sustainable. Yeah, so different routes. Okay, so again, connectivity, also sidewalks, crosswalks, environmental friendly and natural helping. So yeah, so this is again more uh, of of road rail network, how to be utilized in the public environment, in the transportation systems, and how we can share things from one another and then make moving, right? So this is another public transportation routes. What I was thinking to help out is, so we have different radial development systems. So for example, if you look at Hyderabad Metro or Delhi Metro, right? So which is more focused into city center. So city center is there at one place. From the city center, it's a spider web. It's kind of a spider web. It goes up to a farth, right? So if this infrastructure is developed, but this infrastructure is not articulated, so that means the color codes of different routes are not properly designed, or it is not readable, it is not cost effective in the planning. So less people will be using, so that it is not very effective to the current generations to use, current people to use. So whenever there is a transportation planning happening, so this needs to be taken care and more, so that it is more effective. So this is urban development. What I mean to say is, we saw the super blocks earlier. So within the super block, um, the the transit orientation should be there, so that super block becomes more circular and more friendly, and everything is happening within the super block. So that part I like. Another way, in a city example, you can say Bangalore, right? So if we look at in Bangalore, one area, if it take, in that area we will find everything in that area. So person need not to move out for for anything out of that area. So that is one thing which I like. All of them should be walkable distance, and I do not need to, or a person need not go to far distance to find something else. So like that, the transit orientation development should happen. So for example, wherever there is M, all should be concentrated, focused in this area, so that the urban mobility, urban living happens within this area, not to cross functional areas. Mm, yeah, so these are another design examples, design samples for urban living. Shade spaces and traffic calm measures, maybe uh, play streets, open streets, play parks, things like that. Uh, so street parking, instead of having everyone has a parking space, own space, street parking, things like that. So the key takeaways are like, okay, so I have listed down couple of my key takeaways. For example, intelligent transportation systems, right? So the traffic flow, signal flow, real-time monitoring, guidance to the drivers is still not very good. There are lot of AI engines needs to be developed with the different traffic flow directions. The direction of the traffic can be diverted to a different routes, right? So which could help the traffic congestion measures. So depending on the movement of traffic flow, they could guide people to a different routes, so that they will not end up into more delayed um, reach. So shared mobility needs to be improved. So could be car sharing, could be ride sharing, could be private vehicle ownership, so bike sharing, those kind of things. Also EV, electrical related, it reduces the, we all know it reduces the air pollution, but noise pollution, but at the same time, the battery's life is still not high, so that they need to be scrapped after 6 years, 8 years, 10 years, something like that. So which will again a non-sustainable thing. We are look saying it is sustainable by saying electric vehicles, but if you want to scrap a battery, the battery is not easy to scrap. A lot of carbon emissions are going to come out. So autonomous vehicles, self-driving, self-transportation related, those are safe, but still not optimized for the traffic flow. Right, those are still not optimized today, and it is going to take a lot of time to get developed in this autonomous vehicle ingestions. Okay, so and multi transport modes, right? So um, depending on the users, the mobility as a service, right? Mobility as a service is still very low in our development areas. So there are good amount of developments happening in this mobility as service. For example, quick ride, I saw one of the examples. So it could be a mobility as a service. Also Uber shares, things like that are mobility as service, but lot of gaps still in the mobility as service to improve on, so that we have more better transportation facilities available with us. So the benefits and key takeaways, right? So key takeaways, we looked at it. Benefits of smart mobile living, the promises to this, it's reduced traffic congestion. The first foremost aim is reducing traffic congestion, which we are fighting in most of our Indian cities, also bigger cities. So improved sustainability, this is again a biggest challenge. Air pollution and environmental pollution related aspects. So here in London, if a person is having a car which is 2015 or older, they need to pay congestion charges. So the congestion charges are very, very high. If they want to drive into London, they have to pay congestion charges, which is going to be a lot of it is the reasons are, one is congestion, another one is air pollution. So creating air pollution, to reduce the air pollution, they encourage to not to go into the congestion areas. Second is they have also ULH, ultra low emission. There is a zone called ultra low emission. If a person wants to enter with his own car into this ultra low emission zone, they need to pay high charges entering it, exiting it, which will improve the sustainability and which will improve the environment uh, better. So yeah, so enhanced safety, so it could be preventive collision maintenance, reduction of human traffic, human errors, and it will improve the better urban planning, infrastructure growth, economical growth, and all of this. So this is not going to be easy, right? So implementing the smart mobility, MaaS, also urban mobility with sustainable way is not going to be easy, which needs a lot of technology development, as I said. So transportation systems technology developments, we need more sensors, we need more charging stations, we need more 5G infrastructures, um, different development aspects. So data and privacy security is another big aspect, where a lot of personal data is used in different cloud systems, which will may attack uh, cyber, which will open up more cyber attacks, which should be connected networks. Those needs to be taken care. Also equity and accessibility. So citizen living, it's becoming limited access, limited mobility related aspects. So more resistance also could come from the citizens initially, right? So if there is any urban development is happening, there is a recession, there is a resistance from citizens, there is resistance from every part of people, public resistance also, um, also management resistance, everything. Okay. So yeah, future outlook, what we could look at different future aspects, what we are going to play major role as a technology contributors to the society. So more AI related aspects are going to come, and robotics, connectivity will be driving more closest solutions, more analytical, because we need more data to do the analysis of urban living, and to provide more services across over the urban living, which needs more data, so that the more analytics happens overall. And then connectivity is going to be focused on last mile connectivity. It is not only simple connectivity, it's last mile connectivity, which means till the end, till the last person, the connectivity needs to be there. Otherwise, dissatisfaction, or even though spent, but it is not satisfied. So these are a couple of conclusions I could make, right? So um, the key challenges like cost, equity, privacy, and successful deliverables. Also, growth in the modern cities is going to be seen. That growth is going to be addressed by the whole urban living, urban mobility. So, with this, I open up for any questions. Hello, Swati ma'am.
Sir, I have a question. So, by this sustainable mobility planning, how you see India succeeding in it? Because we have mixed traffic and there are lots of different vehicles on the road. At the same time, there is also slow vehicles. How can we incorporate that in the design?
Yeah, so I think our mostly our Indian infrastructure, roads, right? The we have whatever roads were there earlier. We are trying to utilize the same, not thinking of the future, which is going to be right. But even still, wherever we are seeing far areas, still we are not seeing this more used in the sustainable modes, right? um, in the what you can call long societies. Okay, nowadays the society concept is bringing up big time. I see at least the real estate society developments should start looking at the sustainable slow moving vehicles paths. Once that builds, only can be taken care with the sustainability. Yeah, I know in couple of places in India, in Noida, in Gurgaon, there are dedicated cycle paths they are building up. Those dedicated cycle paths are well used. Yeah, but it is not going everywhere, right? If we are going on a bike to office, people think, okay, why he is going on a bike, and he so that mindset needs to go away, I think. Yeah. So there is a poll. Maybe you can just uh, type in questions, answers to that. Any other questions?
Sir, there is a question in the chat if you'd like to answer it.
Yeah, so I see that question about Delhi Metro versus comparing between the two different metros, right? So Delhi Metro is very large model, where it is connecting metropolitan cities, big cities. Also usage and where it is located is also another thing, right? So that's where the groundwork needs to happen before building any new infrastructure. So the infrastructure needs to be used by every public, then only it is going to be it's going to be successful. Also return on investment will be higher. As we also spoke, last mile, right? So the usage of public infrastructure should buy more 40 to 50% of the people. If it is not addressing 40 to 50% of the people, then ROI is difficult to achieve. Also in Delhi Metro, for example, if somebody wants to travel to his work location from one place to another place by car, they take 3 4 hours. But in metro, they go by 40 minutes to 1 hour time. In Hyderabad Metro, what happens is if I want to go to work in my bike or car, it takes only 40 minutes. In metro, if I go, because my house is far, I need to come to metro station. From metro station, I take only 20 minutes. So to come to metro station, I take 30 minutes, and then go to office is 20 minutes. So overall is 50 minutes. And that's the reason I think less usage of metro in Hyderabad. That's what I feel. More usage of transportation still happens with the personal vehicle.
Thank you so much, sir. Thank you.
So I
Any,
believe there are no further questions.
yeah, if anything
And
is there, ma'am, please post it to me. I can answer later. Yeah.
sure, sir. Thank you so much, sir, for all of your valuable insights that you've shared through this session. We appreciate you sharing this expertise on these concepts. So, at the same time, I request everybody to please turn on your videos for 1 minute so that we can have a picture together. Thank you, everybody, for the picture. Now it is time for a short break, and we will be gathering back at 8 p.m., where we will begin our next session. Thank you.
Thank you. Have a good day. Bye.
Thank you, ma'am. Thank you, ma'am.
The stage is all yours.
Yes, good evening to everyone. Am I audible to everyone?
Yes, sir.
Yes, thank you
Yes, sir,
for
you're audible, sir.
introduction. Yeah, so myself, Kotresh, as you got an introduction, so I'm a director of Indian Techies company. It's a like an industry automation sector company where we are going to provide the solutions like from idea to product. Okay, so as you can see, the name of the company is Indian Tech Space Keys. So we believe that so the young engineers of India is the keys for opening that new technology door in India. That's the reason we are into the edutech as well as we are into the industry automation. So that is the main like activities that we conduct in our programs in our company. And we offer the services like idea to product implementation. We take the ideas from industries and we follow the strategies based on the requirement, and we convert that into product with respect to industry automation services as well as the IT services. So we do offer the software products as well as the hardware products. So under the hardware product, as you can see here, we are offering the services like PCB design, embedded system design, and we are offering the services like just a minute. So we are offering the services IoT solutions like 3D print, 3D case design and fabrication, and wire harness and many more. And under IT services, we're into web app development, Android and iOS app development, cloud computing with AWS, and IoT system integration for IT field also, and cyber security system design. So this is our industrial services. So whatever knowledge we gained in this industrial services and experience that we gain, so we are delivering such kind of knowledge and experience through our industry interaction programs. So we do offer the IIPs, industry interaction programs, for the college, for the universities, as well as even for the corporates also. So we are offering the industry interaction programs under PCB design and fabrication, in industrial IoT, in embedded system design, AI ML design, CNC machine design, full stack web and mobile app development, cloud computing, and cyber security. So this is our edutech services. So where we conduct on campus as well as through our company venue also, we are offering the services for the corporates, people who are trying to change their domain or get a experience in a certain domain, and even for the universities on campus as well as off campus also, we are offering the industry interaction programs. And we are having the MOU with the more than 20 plus education institutions in Karnataka, and we are approved by the AICTC also, and we are ISO certified company, and these are all our industry clients. So we work with the RS components, Kia Motors, Pinaka Aero Limited, Aerospace Limited, AO Smith, T Connectivity, and also many more clients are in the list. Under education sector, being alumni of RV College, so I trained many students even in RV University, RV College, Dayanand Sagar, Ramaya University, Cambridge, like this. Many more colleges also have a type with us. So this is the brief introduction about our company, and this is our company address and contact details. Yes, so the main motto of this particular session is about introducing you regarding the IV, so Internet of Vehicles. So before that, just wanted to give us brief introduction regarding the Internet of Things, because when it comes to the IVV, so it's all about internet where we are applying the IoT. It is the application of IoT for the vehicle communications. It means automobile industry. So when it comes to the Internet of Things, of course, maybe you would have some brief introduction regarding the IoT. So here, the thing things are communicating over the internet. Things may be the vehicle. Things may be the machines, objects, animals, people that are provided the unique identifications and ability to transfer the data over the network without requiring any kind of human to human or human to computer interactions. So whether the receiving end is especially monitoring person is available or not, still the vehicle can communicate, the object can communicate, the machines can communicate each other without having any kind of person to trigger the events, or without having any kind of person to monitor the event. So without that, so two embedded system or two automation systems can communicate to each other, and it is going to react to the signal provided by transmitter at the receiver end, and it may also have a full duplex. Of course, when it comes to the IoT, the main four major elements in the IoT, so irrespective of device that we're going to use or application that we're going to use, is a sensors slash devices, connectivity, data processing, and user interface. So when it comes to the sensor, of course, you will be having the idea about this. So it's all about converting a digital, like a physical parameter, into the analog parameter or electrical parameter. So of course, so we have many varieties of sensors in most of the applications, even in the like like home appliances. Also, we have many sensors. Vehicles, we have many sensors, and health applications, we have many sensors. And these sensors data is going to captured by a either processor or controller at the transmitter end, and it is going to be fine tuned. It is going to calibrate the signals, it is going to calibrate the results, and instead of providing the immediate result, it is going to send that information to the cloud, or it may send the information to the any kind of like a cloud infrastructure, so where that information will be received by the any other devices at the cloud, from the cloud to receiver, and it may take action accordingly. Example, like especially the medical appliances. If I have, let you know the information regarding the medical appliances. The patient wearing the smartwatch, so the information regarding the patient health can be captured by the smartwatch. So instead of just indicating the information in the display which is provided for a smartwatch, it can pass that information to the doctor over the cloud, over the internet. And we can also do this one with a local network also, instead of transmitting over the internet. But so what happens, local network has its own mobility issue, as you know. It is not portable. So if the doctor is going out of that particular network, like example, if he is going out of hospital, there is no chance for him to get the information regarding the patient. So in that case, of course, it is always better to have a internet of things, because as we know, necessity is a mother of innovation. So we should have a clear picture why exactly the IoT is required, instead of making it like an intranet of things, why internet of things is required. Then connectivity, of course, when it comes to the connectivity, we need a port or a path to connect to the internet. So the collected data is going to be captured by the processor, and processor can do the all the filtration, everything, as I already mentioned you. And finally, it has to push the data to the cloud. To push the data to the server or the cloud, there is a proper internet connectivity is required. So this is where the major part of the internet of things come into the picture, and it can happen over the Wi-Fi, or it can happen over the WAN. And for the Bluetooth means, from the client to the master. Directly Bluetooth can't give you the internet connectivity, so you have to transmit the data from client to master, and master should have a again the internet connectivity to push the data to the cloud. Then data processing. So the collected data gets into the cloud, and software performs the processing on the gathered data. So sometimes what happens, we may require the internet of things IoT establishment only to connect the two devices. That means the data passed by transmitter is going to received by the user, and it is going to be processed based on the program that we written at the receiving end. And the acknowledgement or the feedback given by the receiver will be given back to the transmitter. And just here, the cloud infrastructure is going to work just like a mediator between the transmitter and receiver, which is going to provide a IoT establishment. But in few cases, example, I can give a case study saying that yes, I have a smartwatch, or I have a one particular device which can capture the um, like the skin disease image of a skin. So now, as soon I capture the image of a skin, so I want to like give the information to the patient saying that this is what the disease you are having, and this is what the like all the kind of like procedure you have to follow in order to cure that particular disease. So in this case, so if I have 100 patients, I can't make all the 100 patients data to reach the doctor, and doctor is going to monitor one by one and give the information to the patient. So So instead of that one, I can write a good ML algorithm and place that one in a cloud server, and where the server can do the task of providing the information related to the patient. Same thing happens even with respect to the vehicle. So whatever happening with the vehicle, so if the user can get the information, so if the vehicle engine is like vehicle getting a less like mileage, or if the vehicle infrastructure, like whatever machines are there inside, if it is not functioning as per the expectation, instead of someone come and attend that particular issue, we can write the ML code where the machine learning algorithm can give the information to the user before somebody come and give the information regarding that. The machine learning algorithm itself can do the processing. So that is about the data processing. So instead of like it can display the mileage graph, it can go through the, of course displaying the mileage graph can happen in the local program itself. So whenever you want to make a cost saving model, so here I said local program. That means if I have a processor in the car, so inside the processor only I can do the concept of ML program. I can do all the tasks and everything. Implementation can be done in the local server itself, local machine itself. But sometime what happens when I want to go for a cost saving model, so this local server, local processing may need a huge amount of processing speed, huge amount of infrastructure. It means with respect to the cost of the device, or it may be with respect to the RAM and ROM of that particular device, it may increase the cost of the entire implementation. So instead of that one, what you can do, you can use a low cost device at the vehicle just to capture the data, not to process nothing, just to capture the data and tune it. Comparison, processing, everything we can do at the cloud infrastructure. So in this case, what we do, so we capture the data, we store the information directly, we send the information to the cloud infrastructure through the web server, and the cloud infrastructure is going to process the data, where we can rely on the AWS services, or many IBM cloud, many are there who can provide the reliable high processing machines, cloud virtual machines. So by using that, we can process the data in a very accurate manner and fast manner, and we can give the information back to the lower end controller processor which is used at the vehicle to display the information. So here the controller processor, whatever it is used in the vehicle, that is acting only as a capture device and display device. It is capturing the information, it is providing the information back to the user, but processing will be happening at the cloud. So that is a one more approach. Then user interface, of course, as I give the information in the previous slide, so it is going to display the information, or it may capture the information, or if the user wants to give the information, of course most of the time we go with the UI design, either maybe web based, or maybe desktop based, or it may be a mobile based, like that. So where we are going to like we are going to develop a web application, or maybe mobile application, or it may be a desktop application to display the data back to the user, or standalone HMI, where data will be given back to the user through that particular user interface. So of course user interface also have a many more things, like especially when it comes to the vehicle. So we can, instead of detecting the drowsiness through the any kind of smartwatch, we can go to the camera based drowsiness detection, where it is helping the user, or helping the like it is preventing lot of damages to the vehicle as well as the user. So it can capture the information regarding the user drowsiness status. It may be a road safety, or anything we can take the data through the user interface elements, like a camera, the mic, or any kind of temperature sensors, like these things, especially camera, mic, HMI, all this comes under user interface. So of course whatever I gave till now, all the examples are there for the internet of things only. So then I'll go to, yeah, talking about the benefits. Of course, when it comes to the organization level benefits, even with respect to the vehicle based benefits, we have a lot of benefits in the internet of things. So it reduces the save the time as well as the money. So example, very simple, like now I have a vehicle, so where my vehicle health is not good. So instead of I am calling a person right from the for a small issue also, if I go to the till the level of mechanical garage, or if I go to the till the level of the standard showrooms, so the travel cost and that repair cost may go beyond the budget. So instead of that one, if anyone the machine level or any kind of supervisor who is sitting at that particular common room or like server room, by observing my health my vehicle condition, it can give the information to the user. Yes, he can go with the so and so steps to clear the issue temporarily. Later you can come to the service like a showroom for getting the service center. So like that, we can integrate internet of things with the vehicle to save the time as well as the money. Sometimes even it may save the life also, as we know. And to make the, like, with respect to the revenue point of view, business point of view, IoT has its own benefit. And like, because of all these information, of course IoT is so important. Like nowadays we can connect everyday object like kitchen appliances, cars, thermostats, baby monitors, many things in a internet via embedded systems. Of course, many times people think embedded system and IoT is totally apart, but to be honest, it is one package. It all are under one umbrella, because IoT provides the establishment, whereas embedded system provides the capturing parameter. So embedded system is the one which is going to capture the information, which is going to provide the information related to the internet. Like it is going to provide the information regarding the transmitter and receiver. If the transmitter and receiver itself is not available, if the capturing sensor capturing elements itself is not working fine, then whatever we do, all these IoT will not be much useful. Yeah, so many are there, like in the IoT applications like thermostats and connected cars, activity trackers, parking sensors, connected health, smart city, many things. So challenges that we face in the IoT, of course, this is one of the important factor that we have to understand. So if whenever we are relying on any kind of technology, say that when we are, especially when it comes to the automobile, so that when we are relying completely on the IoT, example Tesla car, like where IoT is also part of that. Okay, so autonomous vehicle. So we believe that one, okay, system is totally autonomous and I know to drive it. I can simply sleep in the car. I can sit aside without having any kind of more monitoring regarding the steering. So whenever we are providing any such kind of technologies to the users, so we should have a rigorous of testing. If any kind of any point of time, if the testing is not happened properly, or if the things deployed without having much testing, so there is a chances where it may create a like a major accidents, or it may create a lot of losses to the public or to the user, because user is believing our system, and when the system is not properly tested, or when the system is not properly working, it may create a lot of issues. So concern regarding the data security and privacy, of course, very important part. Like whenever my vehicle, it means if I am having a vehicle, it is my property. So if I am having a smartwatch, it is my property. So my property is capturing my data. So my vehicle is having the information regarding my certain like driving pattern, or it may be the history of the travel. Everything will be there in that vehicle. So whenever I'm sending that one to someone server or someone transmitter, so there is a chances where it may be having the security breach. The challenge in the wired and wire, like a challenge in the wireless communication compared to wired communication is, of course, as you know, wired communication is more safer compared to wireless, because in the wired communication, if somebody hack the information, somebody has to hack the information, means they have to literally tap the information. It means they have to cut the wire, or they have to somehow tap the real transmitter and receive like a transceiver channel. But when it comes to the wireless, as you know, it is transmitting over the air. So when it is transmitting over the air, there is no guarantee which third eye is watching you. Even when we both are communicating to each other today, so if this meeting is not happening through the proper security, especially by the company who are providing the meeting link and all those stuff, so we don't have any assurity which third eye is watching our information, or which third eye is attending this particular meeting. Even though they are not present in the meeting link, there is a chance, if the information like security is not properly provided, somebody may access our meeting or presentation or anything. It may be financial transaction, vehicles, anything. It may create an issue. So concern regarding the data security is one of the biggest challenge in the internet of things. Next, when it comes to the data balance and interpretation, so what happens, like whenever we are telling that when we are collecting the data from the vehicle, data from the any kind of like end device, so the next concept comes frequency of collection. What is the how frequently you would like to collect data? So this part is really the biggest challenge for the industries, because whenever I want to store the data in the cloud, so what happens, cloud charges for that. It is not a free of cost. So whenever cloud charges for that one, what they expect is what is the GB you are expecting for this particular device. And when the frequency of capture or frequency of reading is increasing, so what happens, like it is going to create a challenge with respect to the like, yeah, just I was just cross checking whether everything is correct or not. Sorry, was the like presentation stopped? Are you able to see my screen?
Yes. Uh,
Yes, sir. Yes, sir.
Because
yes, sir.
somewhere is it stopped? Please inform na, if any network issues are there and if it is stopped. So you may hear my voice, but you will not be able to see the screen. That's the reason. Yeah, of course, everything is presentation only. That I'm not doing any kind of practical experiments. Yeah. So we were talking about the data balance and interpretation. So that is one of the biggest challenge that we face in IoT, and integration with the AI and with the AI and automation. Of course, as I said, when we attach a IoT in AI for the IoT, it creates the complexity. It increases the complexity, as well as it also creates a like a lot of dependency. If the data coming, like if I'm, let me consider my AI model is capturing the live data, and it is waiting for a live data from the internet. So in this particular case, if the, because of connectivity or because of any reasons, if the AI is not able to capture the live data, if it is missing any one of the readings because of the slow internet or because of any issues, so it may create a false predictions. So because of that reason, it has its own challenges. Yeah, so they're all the like challenges that we face in the IoT, and advantages, of course, many advantages you already saw. So disadvantage, as the number of connected devices increases, more information is shared between the devices, and potential theft or potential that a hacker could steal the confidential information also increases. It is of course like being a human also, whenever we know the information, it is 100% secret. Whenever we tell the information to one person next to us, it is 50% secret. Already 50% confidentiality is went. We can't assure that one, that person will be always loyal and they won't tell to anyone. So whenever the number of people who are in our group, whenever many people are joining our confident group, of course there is a chance of security theft, or there is a chance of like security breach. So these factors happens even in the IoT also. So whenever the number of IoT device connected devices are increasing, so because of increment in the number of devices, it also increase the chances for security breach. Okay. And not only that, one more challenge that we face is with respect to the traffic management. So in internet of things also, a lot of traffic management will be there. So whenever we connect a vehicle to the IoT, of course, so what happens, like not only the vehicle traffic management, even we have to manage the request traffic management, or the incoming request, incoming data traffic. Whenever 100 members or 1000 vehicles or 10,000 vehicles are trying to access a server, to connect each other or to reach the AI model, whatever we deployed in our server. So what happens now, whenever the high amount of request is coming in, a massive amount of request in a short period, so there are the chances where the server may struck. And of course, as you know, in case of central processing concept, whenever we have a central processing unit, or whenever we have a central processing platform, if the central processing is collapsed, so all the remaining end device will get its own like challenges. Like it is going to create a big mess. Okay, that's the reason. The disadvantage that we can face in the IoT is, yes, it is having a lot of benefits, but it is also having a lot of cost cutting parameters because of central processing. At the same time, challenges that we may face is, if that CA, central processing unit, or CPU example, like if that is failed, all the end devices are going to get a like effect of that. Yeah, generally the simple block diagram that we go for the IoT is many cases what happens as soon we tell IoT, many people use their mobile hotspot, the local Wi-Fi for connecting to the internet. But in reality, what happens, like whenever we go for IoT in reality, so like if I use a mobile hotspot or it may be using any modem, so what happens indirectly, my IoT system is also depending on one more system that is called as a modem, hotspot, internet facility. So now challenge is, again, it won't become a portable. It can become a portable within a room or nearby that hotspot. But if the device which is providing that particular internet connection, if it is moving away from that IoT device, then it is not IoT device at all. It is just a local embedded again. That's the reason many of clients, what they expect is, sir, can you provide any kind of IoT system which can be offering the internet through the GPRS rather than mobile hotspot, because that is like how our mobiles are getting the internet nowadays. So mobile can get an internet either through the hotspot of some other person, or it may be through the GPRS communication, that means through the GSM cellular network. So here what happens, like when we provide any kind of solutions with respect to that approach, that can, of course, there also we have challenges that can make the device more portable compared to the method one, because our mobiles are already portable. Wherever we go, if there is any kind of cellular network is available, we do get an internet. That facility, that infrastructure is already present in most of the places on the globe. If we are using such facility, it is more suitable for the IoT applications, especially vehicles, because vehicles are meant for portable. It means it is moving object. So whenever you're providing the moving object, and if you are having any kind of internet facility only because of hotspot or only because of the anyone's mobile support, it won't work. We have to make a vehicle IoT through the GPRS based, like how we are having a one SIM network for our applications. We should also have a one more SIM network for certain, or we have to go for a client, master client communication. So during the next slide, next PPT, I'm going to explain you how exactly the master slave communication is going to work for this particular non-cellular network based IoT. Yes. So any doubts in the till now whatever I presented? Any doubts in that particular presentation? Okay, that's good. That's good. I'm happy for your response, because of course when it comes to the online meeting, that is a challenge. Like we will not be able to know until you are going to speak what's there in your mind, right? That's good. Thank you. Now comes to the one of the applications area of internet, that is internet of vehicles. Okay, so let's see one by one what exactly the internet of vehicles and how we are going to use that. Okay, and of course in these whatever previous explanation I gave, in that one already I covered some of the parts of IV, internet of vehicles. So instead of applying the internet of connectivity between the home appliances, between the only the small models, we're going to connect the ECU or like entire control unit of the vehicle or entire monitoring unit of the vehicle to the another vehicle through the internet, or to the another to the another service station or anything public platform, anything we're going to connect to the internet. That is a simple explanation about that. So IoV is basically internet of vehicle, a strong network between the vehicle and living. Okay, IoT is proposed development of internet in which everyday objects have a network connectivity, allowing them to send and receive the data. So can anyone let me know? Yeah, till now I only spoke. Can you give me the one kind of requirement? Like maybe many of you would have driving the vehicles. So can anyone let me know? Anytime did you experience this? If this parameter is IoT enabled, it might be great. Because I would like to know
The
the
wheel
whether
pressure, wheel pressure.
air pressure.
Yeah,
Sorry,
air
I didn't
pressure.
get.
Yes. Yeah, correct.
Yeah,
Air pressure. Yeah.
it's good. So air pressure. One more, any other question, any other feasibility? So of course, as I got a information, air pressure, that can be that is one of the like applications that you can feel like IoT, but it can also be done by the local processor of that particular car. Because air pressure, like example, let me consider there is a person who is 10 kilometers away from your car. You are there in the car. Okay, in such cases, if that person knows about your air pressure of your the wheel, there will not be much usage. At the same time, if you are the person who is there is no one is present in your car, and if you are there very far away from your vehicle, and you would like to know the status of your vehicle, what is the status, whether my vehicle is completely ready for driving or not, whether air pressure is less or not. In such cases, whatever example you said, it might be more suitable. Of course, both the cases is fine. Anyone experience that one? Yes, I am going to a vehicle, I am going to a city, in certain street, I don't know how many where I can park my vehicle, car parking slot. Anyone? Maybe most of you who already using the vehicle. Biggest challenge in the four-wheeler is parking the vehicle in the safe place, right? So until unless we go and reach, or until unless we call someone of that particular car parking people, we will not come to know what is the slot available, or whether can I book the car parking in early, like before I visit that particular location, or if not car booking in priority or in advance, can I go to that location and get a service done, or get a service as soon I reach that location. Or if I am driving a vehicle, if I search in the internet, can I get a nearby car parking stations available, and how many car parking slots are available in that. So if that kind of facilities are available, it is already available, it's already available in most of the cases. But if it is more modernized and more implemented, it might be great, right? Because we won't get any kind of damage to our vehicles. Already we have a network, GPS is going to give the information which road is having more traffic. But unfortunately, still we don't have information regarding which road is too much damaged, humps and bumps, right? So most of the times what happens, like that information is not provided by any of the um, authority. If whether this road is road closure, they may give, but how many humps are there, how many potholes are there in that road, what is the condition of that road, that information is not yet available. So it might be good if we develop such infrastructure by using a traffic camera, by using the user experience. So if there is any possibility where user can give the experience or rating for that road smoothness or road condition, that might be great. So such kind of facilities also we can provide. Okay. Yeah. So that is about the IoT. That is one of the applications. Many be great if feature, like especially the potholes, right? Potholes point of view, I felt many times, why can't internet give the information this road is not good, or this road condition is not good. Maybe if there is any blockage, it may give the information. If there is a road is damaged because of the potholes, if yesterday night one vehicle went and because of that pothole is created, means today I should get information. Such kind of transparency has to be there. Then only what we can do, we can modernize and we can properly monitor the traffic. Yes, the new era of Internet of Things is driving the evolution of convolution vehicle ad hoc network into the Internet of Things. There is a concept called as the vehicle ad hoc network. So what happens in this particular concept? So as I mentioned, instead of you are connected to the another vehicle through the internet, you are going to connect to the nearby what I can tell, nearby mobile hotspot, or that means not a cellular mobile I'm talking about, nearby like a transmitter, nearby modem, which is already connected to any some other network through the some like a wired or wireless, through some local network. Example, I have a multiple especially walkie talkie. You can check with the concept of walkie talkie. So now traffic and police people are using a walkie talkie. It is not connected to the internet, it is connected to the local radiations itself, it is connected to the local network gate. Okay, as I have information. So here what's happening, like any person can connect to some other person through that common media. Like that vehicle also like we have many vehicle networks in some other countries, maybe it may not be in India as I know. So in some other countries we have such kind of network where whenever I'm traveling in a particular road, I have a one particular roadside transmitter, a roadside trans receiver, where my vehicle trans receiver will connect to that till it is there in that particular coverage area, and like it is going to provide the info, it is going to provide the services like a connect into any other fuel stations or some other like a net more like some other vehicle. So this is related to the local network, local connection or local communication. So of course now the because of IoT, it is moving from a regular vehicle ad hoc network to the Internet of Things. Being in a generation of internet connectivity, there is a need to stay in safe and hassle-free environment. Of course, that is what the benefit of the IoT. So almost most of the vehicles are going to be connected to the network in future. Of course, it's based on the need of the people. Sometimes what happens, we have facilities, we have a benefits, we have a lot of features, but unfortunately people will not be in the level of using such facilities, because people may not feel it like a use for them. So they may feel it, okay, why this particular parameter is required for me. In such cases what happens, there is a chance where you may not be having the proper benefit, or you may not be feeling that particular require like a feature of that particular way technology. Yeah. Yes, IV distributed transport fabric capable of making its own decision about the driving customers to their destinations. Example, like our GPS itself, like it can give the information whether we can use this particular road lane for like reach going to that particular destination or not. Whether instead of this one, it is better to go with some other location, some other path, something like that. Okay, if there is a heavy vehicle movement in that particular road, instead of taking that vehicle, that particular street, we can go with another street. See, now we don't have any information whether, like we know the information whether the traffic is having more in that particular road or not, but we don't know which type of more number of which category vehicles are moving in that particular, whether six wheel, eight wheel, or whether do we have a good flexible like small vehicles passing in that particular street or not. We have information, yes, traffic is more. Traffic can be created because of small two wheeler also. Traffic can be created because of the large vehicles. And when the traffic is created because of the large vehicle, what happens, like we need a like more amount of the we need a more amount of the like time to clear that traffic, right? May I know why the presentation is getting like close oftenly? As I observed, presentation is getting closed oftenly. Okay, let it be. Yes. So that is what the benefit. And IUV should have communication, should have a processing, communication, storage, intelligence, learning, and strong security capability. It is a part. It is not only for IVF, even for the normal internet also it is required. But when the dependency, the area in which our IoT is implemented, and the dependency of that particular technology will make the seriousness of that particular technology. So if I'm using internet of things for medical applications, of course it is more important, more there is no tolerance for the any kind of errors. If it is simple for home automation, pressing the button, turning on the applications, pressing the button and getting the information regarding the industry or home location, like home situations, what is the current situation in the home, that will not create a much challenges. Even though there is a small errors in the result, that is acceptable because it is not going to create a big life damage, or it is not going to create a big issue. But whenever we are implementing a vehicle like IoT, especially for a vehicle, for medical applications, it may create a really life damage. Why? Because the application area is such so much serious or so much delicate area. So in such cases, so security and processing, storage, many things are required, like a lot of things are required to be integrated in IoT framework and smart cities technologies, and extended business models and range of applications, including the immediate oriented current vehicles networks, vehicular network. Yeah, types of the vehicle, like a vehicular communications, vehicle to vehicle. So one thing is one vehicle is going to communicate to another vehicle. So vehicle to roadside unit. So vehicle to roadside unit also we can communicate sometimes, so to get the information. So vehicle to infrastructure of cellular networks, that mean through the like a cellular network we can get the internet connection to that. And vehicle to personal devices. So even though I have a, currently what is happening guys, like we are connecting mobile to the car system through the Bluetooth. There is a chance where vehicle can connect it to the car system through the internet also, where it can make our vehicle system accessible anywhere in the world, instead of only be accessible only, because now currently the car Bluetooth, as you know, when you're sitting in a car, of course it is helping us to operate the music systems or many things. But when you're out of the car, when you're very far from the communication range, it is again difficult. So going with this approach is really good. Especially example now, let me consider I park the vehicle in a certain area where there is a lot of sunrays are there. I can turn on the AC when I go and reach that particular car. But now I want a comfortable environment as soon I enter into the car. So in such cases, if I have any kind of internet connected uh, vehicle system, so where I can turn on the AC before I go and reach the vehicle. So I can turn it on before that I reach, because vehicle will not come to know when I'm going to arrive. But I can give information to the vehicle through the internet, where vehicle can start its system, start the AC, example air conditioner, and make that particular environment good for me as per my convenience. Yeah. Then vehicle to sensors, of course, vehicle to sensor has its own benefit with respect to the example. Let me consider there is uh, one example I can give for a vehicle to sensor. So let me consider there is a traffic light where it is a traffic camera, where it is identified that when there is some smoke is coming out of your vehicle bonnet, example. So in such cases, instead of directly taking it as a like to check the seriousness of problem, I can simply turn on, like as soon there is a smoke is coming from the vehicle, so I can simply give the information to the fire department where there is the vehicle is about to get fire, get caught with a fire. Please go and attend that particular. I can give the information. Instead of that one, why can't you go with the understanding the serious depth of the damage? Very simple, depth of damage or depth of the issue, by reading the sensors of the vehicle to that particular processing unit. That means as soon the camera found any kind of smoke in the vehicle, example nearby the like a traffic, so camera can send the information to that vehicle IP saying that please can you provide the information regarding your sensors readings or your current ECU data. Then if the vehicle is able to provide the information to that particular uh, like processor, it can make a right decision, it can take a decision to the next level. Yes, network of IEV. So a network model of IEV proposed based on the three network elements, of course, cloud, connection, and clients. Okay, so of course you know cloud means it is all about the connecting one end to another end. Connections, how you're going to connect to the cloud, whether you're going to connect the cloud to the through the VNets also you can connect to the cloud. It means uh, local, first your vehicle is going to connect to the roadside station, from there to internet. But roadside station is not a portable, your vehicle is portable. That means it is moving from one location to another location. But your roadside station is not portable, it is not moving from one location to another location. At that time you may get a disconnectivity, or you may get a difficulty whenever you are moving from one place to another place. So that chance will be there. So cellular based network connection is, it's really good. There also we have a challenge, because as you are being a like cell phone users, you already have experience. 100% we can't assure internet in every place. First of all, cellular network only we can't assure in every place. So if we go for a satellite based internet connectivity or satellite based network connectivity, then there is a chance where we can get our internet connectivity wherever we are there in the world, and it is more appropriate for vehicle based vehicle IOV. So applications, so many applications are there: vehicle to vehicle, vehicle to infrastructure, vehicle to cloud, and vehicles to vehicles. So when it comes to the vehicles to vehicles, dynamic wireless exchange of the data between the nearby vehicles that offers the opportunity for a significant safety environment improvement. Example, car connected to car connected to buses. Okay, anyone can you just give me the small experience? Anyone you tried? If two cars are connected to each other, it will be really good through the network. Anytime anybody experienced it? Am I audible?
Yes, sir, you're audible.
Yes, sir.
Yeah,
Yes,
yeah.
sir.
Anytime anyone experienced, yeah, it will be really good if one more car coming in front of me is connected to my car, so that one both can have a some kind of benefit, the users. Yes, especially I felt lot of time, especially whenever people are not ready to reduce the beam of their headlight. So what happens, like they are not bothered about the opposite person. They want a high beam and they want a road clarity whenever, whenever people are coming. Like they will not be bothered about other person who is coming out. So actually, it is advisable that both of them has to reduce the beam light, and they have to reduce the beam to the lower focus, so that opposite vehicle should not get any kind of trouble. But many cases that will not happen, and because of that reason many accidents also happened. So why can't two vehicles communicate to each other, and instead of giving the asking the user to reduce the beam, vehicle itself should reduce the beam as soon it is finding the info any kind of vehicle in the opposite location with a 50 meter 100 like 50 meter or 10-meter distance. It should do automatically that particular part, like it has to reduce the beam automatically, so that when nobody is to request for them to reduce the beam. So these kind of things we would like to create, because it is most needed for many of the people who are traveling, whenever there is a vehicle is in the trouble, or vehicle is, let me consider one vehicle is standing in the roadside. So whenever this vehicle is going, if the vehicle can come to know what is the trouble in that, or if there is any kind of support is required, a network of people who can provide the support. Okay, so such cases we can have a vehicle to vehicle communication, vehicle to buses, connected buses, and vehicle to infrastructure, of course, with respect to the factories, with respect to the hospitals, parking stations, buses, bus stops, and the bridges. So vehicle to infrastructure communication is also really a necessity of the current trend, because whenever we want to reduce the traffic, we would like to have a safe drive. Whenever there is any construction is going on in a certain road, I would like to avoid that particular area. Or if anybody, any kind of school, like especially example, now let me consider I have a location where there is a rule saying that by the government it has to drive within 60 kilometer. That means the speed restriction area. In such cases, why somebody traffic police has to be present in that particular area to reduce, to keep the gun and punish the, like give the penalty to the users who are crossing that particular speed. Instead of that one, why can't we make a vehicle to infrastructure communication, where vehicle is going to communicate to the that particular infrastructure. What is the infrastructure means? That particular locality. If the speed is 60, even though user is pressing the pedal, still it should not go beyond 60. Vehicle itself should monitor the user, rather than vehicle itself should monitor the vehicle by surrounding or local communication, instead of someone else has to stand there and monitor the users. And also with respect to the signals, many cases as I observed, signal will be very far, where we will not come to know whether the vehicle, like signal is about to stop or about to, whether I have to start my vehicle or not. Many cases what happens, people keep starting their vehicle, and they will keep it in a neutral mode, and they will be keep on waiting for the vehicle signal to release, because at that time what happens, CO2 will be released at up to certain level, and vehicle also will be having trouble with respect to the ideal position. So many things may happen. Instead of that one, we can display the live status of the signal, what is the current duration, 30, 20, 30, 28, like that every second. Why can't we display in each and every vehicles? So that one they can take a decision. User can take a decision whether can I pass the this signal or not, whether I have to move to the this particular speed or not. All those things they can take information. So next is vehicle to cloud. Of course, instead of like whatever I explained in the previous slide, so that can happen even through the local communication. There is a one there is one traffic light signal is there in front of my vehicle only. That signal is there. I can transmit the data over the wireless. I don't need to have internet for that. Okay, but whenever I would like to know where and all the traffic signals are there, where is the easy route, or what is the current status, or what is the nearby hospital, or after 5 kilometer, whether I get a hospital after 5 kilometer or for 3 kilometer. Now through the GPS we can do it, but still if it is connected over the internet, it will be more benefit. Accident information, because GPS nowadays, GPS will not give you the accident information, whether the vehicle met with the accident or not. That information will not be available in the GPS. So where with the IoV we can do that. Of course, proposed benefits: smart city, advanced navigation, real-time traffic information, drivers and passengers safety, fuel and cost efficiency, less traffic blocks. So they're all the benefits of the IVV. So VNet, as I mentioned, so it is like an ad hoc manner where the different moving vehicle and other connecting devices come in contact over the wireless medium and exchange the useful information. As I observed, like as I mentioned, VNet, what happens? Like it is going to communicate to the roadside stations, but unfortunately, station is not portable or it is not a movable. So it is not a movable; it is a fixed one. So whenever you are moving from one ad hoc transit receiver to another ad hoc transit receiver, if the distance is very long, in between you will not have any kind of connection. One second thing is installing these ad hoc network in the remote station like a jungle or forest area. It is very difficult because anybody may can come and damage that. But whenever we have a cellular network based internet connectivity or IoT based vehicle monitoring system, so where any vehicle, anyone come when you have a signal in your mobile, even though any animals come or anybody come in front of your vehicle, they will not be able to damage that until unless human has a signal blocking device. They will not be able to damage your internet connectivity. So VNet cannot provide a whole global sustainable services and applications for the customers. So roadblocks in internet infrastructure, cost consuming, software upgradation is challenging, privacy and security, remote area. So they're all the challenges that we face in the VNet. Then future experts, so online vehicle, global internet ID, and on-road internet, smart terminal, and car payment. They're all the benefits of like internet of vehicles. So let's see one by one. So online vehicle. So what we can do is whenever the vehicle is connected over the internet, I mean to the common facility. So each vehicle would be online right from the completion of manufacturing up to the usage by the customers. Currently, what's happening if I purchase a car, if once the car is sold by the that particular service station or showroom, the manufacturer will not come to know who is driving that, what is the condition. They should again get the feedback through the anyone review platform or anyone, how the car is actually how the user is experiencing the car and what is the improvements they can do in that particular vehicle. Until unless there is no network of connectivity where they can get the information, or their R&D team can get the information without invoking or without knocking any one particular users, that facility is not available. Whereas through the online vehicle you can do that. Okay, so the services include status of the vehicle, annual inspection report by the authority, roadside tax payment, road tax payment status, repair and service history. The management cost of the vehicle would be drastically reduced. This is due to the online availability and timely intimation of the service related information. So these are all the benefit, especially. So example, now the police are standing next to the road to check whether the internet, like whether they have a insurance or not. Okay, so why can't we make a like online way? Of course, being a user, it is drawback to us, but as per the law, it is more suitable. Why? Because if I am driving my vehicle, if my vehicle is coming near the road, that means I am driving the vehicle. As soon I am driving the vehicle should communicate, or the traffic camera can capture the information regarding the vehicle ID or maybe registration number, anything. So traffic, if the vehicle live status is present over the internet, okay. So what we can do, as soon the vehicle is coming near the any kind of traffic area or near the road, if there is a lack of any kind of insurance or emission test or any vehicle documents, immediately that user will get the fine. So it's something like user has to follow the rules if they want to drive the vehicle. Very simple. User has to follow the rules. As soon user is boycotting the rules, whether the police is present or not, whether somebody is present in front of the road or not, that will not matter at all. They are going to get a penalty. Indirectly, what happens? The rules which are made for following, the rules which are made for safety of user is definitely going to be followed by the users. So global ID, global internet ID. So each vehicle would have a unique identifiable number in the internet, which is prerequisite for the online presence of the vehicle. Instead of disinfections, GPS-based identification is started by the various global organization of the government for enhancing the safety in the public transport. The global ID would eliminate the need of GPS. So whenever, of course, because nowadays what happened, my laptop, I can easily identify the location of my laptop if I connect it to the internet. Why? Because so internet is going to so as soon internet connection is there. So what it is going to do? It is going to provide the like server details. Server based GPS location identification can be done with using the internet. And then on-road internet, so reliable internet services in the vehicle would add a new devices in online cyberspace in a large value. This is due to the inclusion of all the on-road vehicles. Okay, so this will open a new research and development themes in protecting the online privacy and generating the trusted ID. So it has its own benefit on-road internet. Smart terminal. So machine to machine communication based on the smart terminals would be on demand for both in vehicle and handset usage. So terminal would be capable to provide the most of the vehicle most of the location based services by collaborating with the IoV. So it has its own, like again, as I mentioned, we can get the complete details where exactly the nearby service station is there, if my fuel is getting reduced or it is not having enough fuel to deal with the requirement. So my vehicle can give the information, please refill your fuel before you get any trouble, or like anyhow nearby we have one particular petrol station within 5 kilometers. If you're not, like, let me consider my vehicle is having the fuel of only 10 kilometer capacity, 10 kilometer it can drive. So now what I have to do, I only have to monitor that. I have to check whether the fuel is less or not. Then I have to check in the Google map whether there is any fuel station or not. Then I have to drive and I have to get the petrol done. Sometime what happens, we feel okay, next we may have one more fuel station, or next fuel station we can refill the petrol. Like that we will go to the next level. But the problem what happens here, if the fuel station is closed or lack of petrol or lack of service, so now you are in total trouble. So instead of that one, if the fuel station is also connected to the internet and your vehicle is also connected to the internet, vehicle only will guide you. So the next fuel station is not working because of service issue. So please refill your vehicle now itself in the upcoming fuel station within a 2 to 5 kilometer, like 5 kilometer example. So at that time, what happens? My vehicle, finally being a user, I'm in a safe hands. Okay. And also it is going to open up the marketing for the particular brand fuels. The car payment. So unique cyberspace identity would enable the car payment, the information of the driver or the owner of the vehicle, and would become an alternative of a mobile payment. It means, so because of the there is identification of ID for every vehicle. So as soon the ID is scanned, so owner information will come into the picture. So like person who is the owner of that particular vehicle, and if the User ID is also, that means driver ID. Like example, let me consider I would like to start the car after only I am scanning my driver, that means DL, which is a smart connected DL. That means smart card, RFID enabled. So if I scan the RFID enabled card only, I can get the car service. That means I can drive the car. Means as soon as I scan my information, that means the person who is driving the car will be registered in the network. It means if any accidents or any signal jump, anything happens, now what's happening for signal jump, they are giving the penalty for the car owners. Okay, if any accident or any signal jump, they are getting the penalty for car owners. At the same time, the driver is also responsible for that, not only car owners. So in that cases, what we can do, whenever there is any kind of signal jump or any kind of issues happened by the driver also should get a penalty. It may be penalty with respect to any kind of ID identification. All this can happen only when everything is connected to the internet. Okay, and not only that, so fuel refilling, toll collections, parking collections, road tax collections, and even payment for the service
Yeah.
and management, everything can happen whenever there is a IoV, car payment benefit. Okay, so this was all the information I wanted to share. So just wanted to get any kind of doubts or any kind of questions or discussion that we can do. Yes, am I audible?
Yes, sir.
Yes, sir. Yes.
Yeah. So any discussion can we do each other? So or any kind of information you want in brief, or any experience you are having, you can also share it, so that when it will become a good knowledgeable sharing session. So we'd like to work with you all, since you're from the like different space, like a different colleges and universities. So can we get a vehicle trajectory data? Starlink and Elon Musk Internet of Service, so we can get any advantage of this. Exactly true. So of course, the challenge that what happens in this particular few countries where still people are not following the rules, especially Tesla won't be suitable for India, as you know, because still see, technology is not only important, we also should have a supporting or people who are following that one properly. So that also counts a lot. So of course there is a lot of benefit, not with the IoV. So we should create that awareness, and also we should show the benefit to the according to me, we should create a necessity first. Many times what happens in education sector also, as we saw, being an industry expert, I feel the people are not knowing the necessity of that particular feature of technology first. We tell them the necessity through theory. Yes, this is what the necessity of this technology. But unfortunately, we may not get enough time to make them to feel the necessity. So I feel that one we should first make the public to feel about the necessity. Yes, why IVB is required, why Internet of Things is required, or why Internet of Things is required for this particular vehicle field, automobile field. So when the necessity is felt, automatically what happens? People feel that yes, I have to go for this, selecting this particular like a platform. So when many people are selecting that platform, of course, many industries will come up, and when the number of users are increased, the cost of implementation is up. Automatically, it will be reduced. So cost of implementation is automatically it is going to reduce. Today, cellular network is the best example for that. So initially, when only 1 or 2 members or only 10 members in the city or only 100 members of city in the city are having the mobile, they used to get a lot of charges per call because only for 10 members they have to maintain such a good like a huge amount of infrastructure, and they have to invest infrastructure only for 10 100,000 members. When number of users are increased, the cost is reduced like anything. Why? Because whenever number of people are increased, the infrastructure cost is going to reduce, divide among all the users. So because of that reason, automatically it is going to reflect the cost per user. So we have to create awareness, and we should also feel, because I always tell necessity is the mother of innovation. We have to understand the necessity. We have to understand the necessity. Even for if we are having the vehicle, let's not somebody come and create a IVV for that. We can also create a IVV for our vehicles. So we have to understand that how we can do. And also most of the time, what I expect is like add-on device. Let me consider I have already a vehicle. By adding a certain module to that, I want to convert that as a IUV. So such kind of development is also required. Many times we always think new technology should be implementable only for new vehicles. But if you see on the road, number of existing vehicles are more compared to number of new vehicles. That means new vehicles are yet to come. It is a purchasing rate will be there, but at the same time number of already existing vehicles will be almost, it will be in a huge number. So if any kind of like any kind of technology we develop where we can implement that one for existing vehicles, we can adopt that one for existing vehicles as a plug-in model, that really reaches lot of people. That really reaches lot of people. So we should work towards that area where we use that information, that existing technology for existing vehicles as an add-on. So if I just invest another 10,000 rupees, I should get IV and my convert my vehicle into IVV, provided my vehicle has already monitoring system. So I should be able to convert IVV. This is a lot of industry demand. So many industries come to our company saying that, sir, we have a plant already which is running from 80 years, 100 years, like that. So I would like to convert that into I would like to monitor that one over the IoT. But it's not mean that you have to ask me to install a new version of existing machine. Example, one CNC machine will be there. Now I'd like to control that CNC machine using the internet. So if I tell, sir, go for a new machine which is recently launched by so and so company, so you can resell, you can sell your existing machine and go with the new machine. Then they will tell, sir, just because of one small facility of watching that one or monitoring that one over the internet, why I have to invest in new machine? Why I have to invest so much amount? That question definitely rise. So always we should work towards adopting a new technology for existing infrastructure. That creates a lot of revenue, as well as a revenue point of view. It may be less because just because I added a new part, I may sell the new product with the high amount of price. When I go for a add-on model for existing vehicle, of course there we may face the issue for the revenue point of view. But the technology reaching the people, more number of people who are going to use the technology will increase. That has its own benefit. So even now we have a lot of challenges in the industry perspective. That's the reason in most of the cases we do suggest the candidates, students, industry experts work on the requirement rather than understand the requirement first, and try to provide the technical solution for that. That itself will become a project, and if it is properly tuned, that itself will become a product. So everything has its own add-on. Yes, then if any questions are there, means we can discuss, else we can close the session.
Thank you so much, sir, for clearing all the questions and for giving us such an informative session. Thank you everybody for attending. We will be having tomorrow's session at 6 p.m. sharp once again. So we'll see you all there tomorrow. Thank you.
Thank you all for your valuable presence. Hope it made useful for you. So, you can
Sir,
reach us
one
by
minute,
typing.
sir.
Yeah,
Can
please.
you please turn on your video, sir? We'll take one picture, sir, for session 2.
Yeah, sure.
Thank you, sir. Thank you for sharing valuable insights of IoV, sir.
Madam, what about Sakla? Madam, what about attendance link?
Sir, attendance will be considered as by Zoom will take, sir.
Okay, madam. Thank you.
Thank you all.
Hello, madam. Madam, questions వచ్చినాయి అటెండెన్స్ జూమ్ నుంచి తీసుకుంటారట అదే పెట్టండి ఫస్ట్ ది సెకండ్ ఆన్సరా అఖిల ఫస్ట్ ది సెకండ్ ఆన్సర్
Hierarchical, DSRC.